Mr. Davies' dose of science. If this is your first time learning with us, welcome. If not, welcome back. Hello, everyone. It's Mr. Davies with your dose of science. Hope you're all doing well and you're feeling healthy. We've been talking about the three different states of matter. We've already looked at solids, liquids, and today we're going to talk about gases. We'll use a PowerPoint and Canvas. We'll take a couple of notes. Inside your flap, there is a space for a couple of notes, so make sure you're ready for that. Here we have the slide on gases. For your notes especially, gases do not have a definite shape, nor do they have a definite volume. They want to disperse, they want to spread out. The particles of gases are far apart from each other. They're not squeezed together. They want to spread out. In your foldable, you're going to want to add that information to this last flap right at the top. Don't forget. Also, inside the flap, we've been using an example of fresh water. When fresh water changes from a liquid, water, to a gas, we call that either water vapor or steam. When it goes from a liquid to a gas, that's referred to as evaporating or evaporation. And that happens at 212 degrees Fahrenheit or 100 degrees Celsius. When it goes from a gas, water vapor or steam, back down to a liquid, that's called condensing or condensation. It might be easier for you to see on the next slide. So here we have water as a solid, ice. It melts to a liquid and becomes water. Could evaporate to steam or water vapor. Then as it cools, it would condense and become liquid water again. And if it cools even more, it might freeze and become a solid of ice. If there's a substance that skips a step, for example, if it goes directly from a solid to a gas, that's a different process. That process is called sublimation. When particles of a solid go straight to a gas and skip the liquid stage. A good example of that would be dry ice. So as I was getting ready for our lesson today, I wasn't sure how I could actually prove this to you guys. I mean, I think you know what gases are. We know that our atmosphere is made up of gases, but we can't really see them. And they're so dispersed, they're all sort of collected together. So how do you know that a gas is actually matter? Well, if you can isolate it and contain it and put it in something, perhaps it could be useful. I mean, I have some compressed air here that I happen to use all the time to clean off my nasty keyboard, and that's very handy. I've even used it to blast things out of my little outboard motor. But how do you know that there's actually something there? Well, you can tell because it's got the ability to push something or move it. But is it actually matter? One of my first thoughts was to try and prove that it had mass. I was originally going to use a metal hanger. No, mommy dearest, no metal hangers. Oh, sorry. But I was going to use the balloons my mother sent me at my last birthday, and if I was able to connect one on one side and the other on the opposite side, I was hoping that they would balance, and it really didn't. It wasn't a good demonstration. But if you have two balloons and you want to try this at home, this might work. It's just not sensitive enough for my demonstration. So I decided to try something different. Okay, so luckily I grabbed this OHAS digital scale before we left the building, and I've placed a plastic tray to help with this demonstration, but I zeroed the scale. So as you can see, it's registering 0 grams with nothing in the pan. When I place the balloon, an empty balloon, in the pan, it weighs a mere, or has a mass of a mere 3 grams. If gas has mass, then when I blow up this balloon, and I should let you know it's the same balloon. If I blow this up all the way, and put it back on the digital scale, hopefully the gas inside the balloon will have just enough mass to show us that there's more mass in the balloon with it inflated than there is. As always, please stay healthy, stay safe. Until next time, this is Mr. Davies. Have a great day and keep on learning. If you learned something today, please like this video. If you think there is more you can learn, then click subscribe or consider coming back again tomorrow. The information, likenesses, and opinions in this video are the intellectual property of Mr. Mike Davies. While Mr. Davies does refer to other works owned by others, those resources are either parts of a public school district curriculum or they are readily available through open forums on the internet. Mr. Davies does offer his thanks and appreciation to any entity he has chosen to refer to or gather sound bites or clips from to emphasize his lessons. Mr. Davies is currently a professional member of the teaching staff for Central Dauphin School District in Harrisburg, Pennsylvania, and is making, producing, and publishing these videos for the benefit of his students and other students during the current lockdown crisis. Mr. Davies does not make claim to all of the ideas and resources referenced in his videos. However, he does claim responsibility and rights to his likeness, opinions, and the academic content of these videos. He does not grant permission for any entity to copy or duplicate any portion of this video or any of his videos for private or personal gain.